Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovich, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
So one thing that I've seen change, and I think for the better, is that across aviation and aerospace, the fact that we have these emerging sectors that are actually making things very exciting between the hydrogen, eVTOL, we have new space, commercial space, and the innovation that's enabled by new technologies, and yes, by some forcing functions such as ESG focus, etc., I think is very exciting because we can use this to attract new talent into the industry, maybe to compete with some other industries for talent, and just to get some passion back into aerospace.
Hey, welcome to 2024, to the Vertical Space, and to our conversation with Dr. Valerie Manning, Chief Commercial Officer of Overair. Have you noticed that often our guests have just amazing backgrounds, which lead to responses with multiple layers of depth and an appreciation of aviation, how vehicles are built, use cases, and the value to transportation to society? Well, Dr. Manning is one of those people, and this is one of those discussions. So how do we summarize our talk? This is a discussion around the value of advanced air mobility, of eVTOLs, and Overair's unique value to meet these requirements. So we've had this discussion many times on the value of advanced air mobility in eVTOLs, but it changes over time and of course based on the experience, education, and the workplace of the person responding. And so as such, this is a conversation with Valerie that's really worth listening to. In preparing for the podcast, I was really intrigued with Overair and a solid technical foundation. We really don't get into great detail on Overair, and although Valerie does provide some perspective on what they've done, what they're doing, and what they plan to build, I would encourage you to learn more about the company. They have a foundation of aviation competence that not everyone shares as they build their new aircraft in this new space. We discussed the state of advanced air mobility market today compared to several years ago, the most notable milestones, what's not getting enough attention, and the road to commercialization. We then discuss what has changed about the viability and the use case of eVTOLs in the last several years, both positive and otherwise. We spent a bit of time discussing whether or not there's a real first mover advantage in advanced air mobility, comparing Boeing's potential advantage in the early days of aviation, and perhaps where Overair may have a slow mover advantage as their vehicle will learn from the experiences and the learning curve of the initial launch vehicles and early stage eVTOL markets. For a lot of reasons, Overair could be in a really strong position. We then discussed Valerie's work as Chief Commercial Officer, what the role entails, a bit about their go-to-market strategy, and a more detailed discussion around the trade-off between selling aircraft and operating transportation networks. The jury is still out on the size of the eVTOL and advanced air mobility market. We've learned a lot, even in the last 2 years we've been having these podcast discussions, but it's hard to argue that leaders like Dr. Valerie Manning and companies like Overair, with their thoughtful and careful approach, are more likely to be one of the winners. Valerie, thanks for joining us, and to our listeners, enjoy our talk with Dr. Valerie Manning as you, in 2024, innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Dr. Valerie Manning is the Chief Commercial Officer of Overair, an electric vertical takeoff and landing company in the advanced air mobility sector. In this role, Dr. Manning leads development and execution of the business, including product and performance requirements, business development and strategy, government affairs, mobility operations, and in-service support and services. Prior to joining Overair in September of 22, Dr. Manning served in several global senior executive P&L roles at Airbus and Europe, including Senior VP of Training and Flight Operations, Senior VP of Customer Support, and VP of Upgrade Services. A retired United States Air Force officer and former McKinsey & Company consultant, Dr. Manning is an active commercial pilot and flight instructor with an Airbus A320 type rating and an EASA air transport pilot license. Dr. Manning graduated from Princeton University with a BS in Mechanical and Aerospace Engineering and from Stanford University with an MS and a PhD in Aeronautics and Astronautics.
Valerie, welcome to the Vertical Space. It's a great pleasure to have you on.
No, thanks so much. It's a pleasure to be here. I'm a big fan of the podcast.
The first question we usually ask, one thing that very few in the industry agree with you on.
Oh yeah, I expected this one, and I think I'll make this a little personal, but then tie this back, I think, to our industry sector, which is I am a pilot, but I did all of my initial training from zero all the way up to the ATPL, flight instruction, everything in Europe, in France. Now I'm back in the US and I'm flying here, and everybody around the general aviation industry is like, wow, it's so hard and so expensive to fly in Europe. That's what we hear, and it must be so much better in the US. And I'm like, I don't know what you're talking about, right? It's at least in France, yeah, you can just go to the airfield 6 kilometers from my house, hop in the aircraft, fly to any of 10 or so close by airports, towered, untowered, class Golf to Delta, grass paved, any instrument approach you could want, and then land and go home, right? And it's similar here, except there's none of this like fearful Bravo in France, so maybe that's what makes it easier here. But no, to be fair, yeah, some airports do charge a lot. We don't have the FBO system, so it's just different. But I do love flying here in the US as well. I think I've flown to 20 countries and 90 or so airfields across Europe, and it's great fun and quite welcoming. So I just want to put that out there. But bringing it back to eVTOL, there is an eVTOL angle which relates to the corridors and segregation. I think that's a longer point. And this is an area where I don't know if there's so much disagreement, but we need to come to some kind of accord as to how are we going to proliferate eVTOL around the world, given that it's so different in every country, how they're accustomed to relatively low and relatively slow aircraft.
So what would the industry consensus be on that topic, and what's your diverging viewpoint?
Well, I would say that I don't know that there's consensus, but I think at least here in the US and for much of Europe, which are the two areas I know, is that we just don't need to start in the near term with the aim of trying to define particular corridors and particular segregation at the beginning, because the ramp up is not going to be from 0 to 100, where suddenly there's hundreds of aircraft or thousands of aircraft flying around overhead. At the rate that I believe I see in many places, the uptake being, I think that we can fit in as the GA rules are working today, and then over time we can see, yes, what communication aspects might need to be adopted, what perhaps in some areas what corridors might be adopted. So I just think that's something we shouldn't constrain ourselves from the beginning, but to see how behavior adapts and adapt along with it. It's something that will need to come, but technology is evolving. I think some of our customs are evolving. The airspace itself is evolving, and I think we should evolve along with it and not constrain ourselves right from the beginning.
Let's do a bit of a recap of the eVTOL market, going back maybe 3-5 years, however many years in the past you want to go, and highlight some of the key milestones, big wins, persistent, strong headwinds, the change in stakeholder sentiment, or any key things that you observed over the last 5 years in the industry.
Yeah, well, in this industry sector anyway, 5 years is a long time. I have a long career in let's say, more traditional big aviation. And so until just over a year ago, I was observing this industry. So, of course, we had a period in traditional aviation during COVID where there was just an extreme amount of uncertainty. And one thing that I found, and the whole question was, when is it coming back? How is it coming back? But I think and it largely has. There are some things that are lagging, but largely has. And our industry is extremely resilient. So one thing that I've seen change, and I think for the better, is that across aviation and aerospace, the fact that we have these emerging sectors that are actually making things very exciting between the hydrogen, eVTOL, we have new space, commercial space, and the innovation that's enabled by new technologies, and yes, by some forcing functions such as ESG focus, etc., I think is very exciting because we can use this to attract new talent into the industry, maybe to compete with some other industries for talent, and just to get some passion back into aerospace. I'm an aerospace engineer, Air Force veteran. Aviation is really my life, and I would love to get another generation of players that feel the same way about it.
So what do you remember as key moments for this particular sector of the industry over the last several years?
Well, as an observer, when I was starting to think about coming into this sector of advanced air mobility, or eVTOL, I had some friends who had moved into it, was talking to them. Something that really sticks out to me is the financial moves in 2021 with the SPAC boom, et cetera, and the amount of money that was going into it. And I know this was happening in some other industries as well, but just to see, wow, all of a sudden an influx of money, and also to see that it, to some, and I think in some cases it's for better and for worse. For some, this wasn't so much an aviation play as a transportation play, right? So you're attracting different money, different players, which maybe gets things, at least at that time, moving at a different pace. But that really was a point to me in 21 of saying, wow, this is really a shift that we hadn't seen before.
Valerie, based on the SPAC years of a couple of years ago, what do you think has most changed as it relates to the perception and the value of advanced air mobility and eVTOLs?
Yeah, I really think that the sort of sobering reality has hit on the part of AAM that is aviation, is that hitting the face of realities of regulation, hitting the face of realities of the supply chain, meaning how do we set up and certify every aspect of the aircraft. Realizing that this is a relatively long-term play. I think for traditional aviation, eVTOL AAM is moving at an extremely rapid pace, but for things like more digital industries, it's moving at a slow pace, right? Which means that maybe that return on investment isn't quite, that business case isn't quite exactly what people expected. So I think, though, that kind of slowing down a little bit relative to perhaps what some people thought at the beginning is a good thing, but still it's a forcing function for traditional aviation to think, hey, how can we do things differently? So that's why I think these kind of colliding cultures have come to hopefully create something great going forward now.
Valerie, do you think there are any lessons that we can learn from the culture that SpaceX created and how they straddled the velocity of technology development with the necessities of working in a regulated space and working on complex systems that have to come together at launch and ultimately reach levels of safety thresholds? We've been grappling in advanced air mobility with this intersection of two cultures. Any insights that you see from that in terms of what is the right mix and what wins?
There's really no one answer to that. I will just say, if you think about SpaceX and some others, is, well, not too many others really, I would say, is this idea of we know where we want to go. We know that we have to achieve a certain level of, yes, safety, regulation, etc., and we put those boundaries in place. Other than that, everything's on the table, meaning new ways of thinking, and really, I imagine, not going back to, well, it hasn't been done before, right? This is something where, and since you do have a mix of cultures of, let's say, aviation or aerospace traditionalists and then new entrants, is not to say always compare yourself to how long things have taken in the past, how hard things were in the past, and to move into how, like, a problem solving. What's the opportunity here? So it's really a delicate balance, I would say. And here I'm just talking about, not even talking about operations, but just about getting the aircraft flying, getting the aircraft certified. And it's not only about the OEMs and the operators, right? The regulators are understandably struggling with this as well, because there are so many new technologies, new configurations, everything to play at once. But it's so much about mindset, and I don't think there's one right answer.
So on the theme of the sobering reality that you mentioned before, where do you see the biggest buckets of risk as it relates to bringing eVTOLs to market? Is it in the certification of the various technologies involved? Is it in the maturation of the supply chain, the operations themselves, or just the uncertainty on the domain? Where do you see the biggest risk, and how do you prioritize the organization around those?
Yeah, well, you've certainly hit on several of them. Some are technical risk, some are business risk. There are several categories of risks, and I think on any given day, one or another seems to stand at the forefront. But I think fundamentally we're trying to create business here and create business value within the regulatory environment, within the safety constraints that we all know and love. And one of the reasons I chose Overair is because I thought really there were the fundamentals, including technical fundamentals, to create that real long-term business value. And it does come down to having a vehicle that's fit for purpose. I see these vehicles, these eVTOL vehicles, as basically it's a utility, right? We're creating a utility. How can we safely and effectively move people and goods to create business value along the value chain? And we talk about, for example, regulatory risk and how do we certify? Well, there are some that are moving quickly or trying to move quickly and pave that path. How do we get through regulation? Those aren't all necessarily the configurations that can go faster, not always necessarily the configurations that will create long-term business value. And as an aviation business person, that fundamental ability to create business value along the value chain is what attracts me quite a lot. So it'll be interesting to see who has that patience of waiting for wave 2 or even wave 1.5 to get to that value. But even so, I think another one of the risks in creating business value is how narrow or wide do you see the use cases, the ability to address markets, right? That's another thing with the combination of the size that we can have with the Overair Butterfly, being able to have a tilt rotor. We have this utility in mind, being able to address a broad range of use cases with one vehicle, whether you're moving people in terms of VIP or passenger commuting, whether you're moving volume-constrained cargo, whether it's medical transport. I think this versatility is something that can help address and mitigate the risks. I think another risk that has come up, of course, is around things like the ecosystem, the infrastructure that's there. Here, this one I personally worry about less, especially if you have a range of use cases, because in many parts of the world, there's so much underutilized infrastructure that we can start with that as we finalize really getting that community acceptance point going so that vertiports can go in certain urban areas, which I'll get to in a moment. I think that really we can utilize the infrastructure that exists. And then I think a risk that is a huge one for me towards business value creation is about adoption related to noise, right? It's now you come back to what's the holy grail of scaling in the future? It is that sort of commuter or that sort of end-to-end cargo or being able to get into urban areas. That's going to matter. And here, communities are not always going to be very accepting. So we want to make sure that the perception of noise, pushing noise regulations, that is something that's very key. And that's something that we're designing the Overair Butterfly around is really that noise footprint.
You mentioned the first wave and the second wave of airframers. What's it like being an airframer in each of those waves of vehicles that are coming to market? Who do you think is in the first wave? Who's in the second? What are the pros and cons of being in each?
Well, I mean, we know who are the ones who are really trying to fly first or certify first in 24, 25. I think some of the pros there are if you're fast moving, and especially if you're in a situation where you have shareholder needs to meet. If you're a public company, then you have some shareholder needs to meet that are more near term, and that makes a lot of sense. It also gives some level, potentially a first mover advantage if the configuration is something that can support value creation again. And I think that's an advantage for those companies, but it's also a bit of an advantage for the rest of us so that we can see how will we need to navigate the regulatory environment, the business environment, and maybe some market first mover advantage. But there are so many markets around the world to address that I don't think there's too much danger in being squeezed out and not being able to find a market niche. I think one of the advantages of coming just after, as I said, is yes, taking advantage of the regulators being a bit more savvy in what they want to do, and also just simply taking the time to develop some of the technologies that might take a little longer, right? Overair started, I would say, a little bit later, and of course we're adapting fabulous technology that has been developed over decades in the past and now electrifying it and applying it to the civil market. That is going to be an advantage, I believe, because we're going to have that time to develop a vehicle that is, as I said before, it's one vehicle that can serve several missions with minimal adaptation, minimal configuration change in terms of the vehicle itself. Everything can happen in the cabin. I think also the way I see it is it's, again, what we address here in building the business at Overair, it's a lot more than the vehicle itself. There's a lot that goes on around a vehicle, whether it's traditional aviation or eVTOL, that's necessary, right? There's the training, there's the maintenance, there's the software, there's the, as we said, infrastructure, the concept of operations that will take time to adapt. So we're taking advantage of that. So I think by the time we come to service, and we are focused on that kind of 2028 timeframe, we'll be able to come, I think, with a little bit more of a holistic, arguably a more holistic offering.
Hey, thanks, Valerie. Hey, a question for you based on what you just said as the Chief Commercial Officer. Is your greater challenge defining the use cases of advanced air mobility? Or is it defining Overair's and Butterfly's role or place in advanced air mobility? You're really doing two things, aren't you? As you come from big aviation, you are first trying to decide what's the real value of these things. And you're creating that value amongst the other players in the space. So is that the bigger challenge? Or is the bigger challenge defining Overair's place in that world?
That's an excellent way of putting it. I mean, it's funny, Ben Tigner, the CEO, and when I was coming, we're like, what should we call my role, right? Chief Commercial Officer, because I think I have probably the broadest definition of Chief Commercial Officer that I've ever seen in the industry, I think, which of course comes down to getting our product out to market, but it's also defining what are those markets, it's defining what are the use cases, the concept of operation, the performance needs of the vehicle, the industrial design aspect of the vehicle, of course, all the software that's related, and the training and services, etc. So it is a mix of what you're saying there. In a way, the adage of is eVTOL a hammer looking for a nail? The nails are there. What I'm trying to do, because of the fact that the vehicle that the company had already started to create before I got here lent itself to being quiet, fast, as only really fundamentally tilt rotors can be, and relatively large and high volume, I just saw like, wow, okay, this can do a lot of things. So then it's a little bit doing both, figuring out how we fit in, but we can fit in most places, I would say. It's really thinking about where do we go and at what stage do we address which market, because I think that the use cases will evolve at different pace, at different rates, right? This sort of, as I said before, like holy grail of people commuting to and from work or going to the ball game or the ride sharing, that's where huge volume can come, but that's coming later, right? What's coming earlier? Things that are a bit more either scheduled or some helicopter replacement, or some specific known use cases like a cargo, a medical transport. This is what comes earlier, and I think not necessarily every vehicle is suited for that. Yes, of course, we have airport shuttle, which is quite logical because you have established infrastructure already on one side, so that's very helpful for everybody. So I think it's really a mix of both. Now, with that comes as well geography, like where are we going? And I think part of value creation today is making sure that communities and locales, be it urban, rural, that they understand how to take advantage of these vehicles. So creating markets, that's, for example, what we are trying to do in working with the Dallas-Fort Worth airport, with the city of Arlington, with that whole region there, because this is a region that's like, we want this. How can we use this? But we're not sure exactly what to do. So we're not just in there saying, here, take our vehicle. We're in there sitting with them and say, okay, this is how the vertiport could work. This is what we think we need. This is the technological development. This is the workforce development that's needed, right? Everything that goes around it as well. So you laid out two aspects, the kind of the give and take. And yes, indeed, I think that's equally challenging, the give and the take that I'm trying to develop here at Overair.
So being in the first wave of vehicle developers coming to market, it definitely resonates with me that you build a vehicle that is versatile and multi-purpose as to the mission that you fly, because we have a lot to learn from actually flying these vehicles. And I think it's a safe assumption that the second wave of vehicle manufacturers are going to be designing some of those learnings into their vehicles. So in this first wave, I have to ask the question, how likely is it that the first generation of vehicles are going to be in the market long enough that they scale up to mass production? Or will it be second generation revisions of those vehicles that are ultimately the ones that scale up? Likewise, the first generation companies are doing a lot of internal development of propulsion systems and of other subsystems integrated into the vehicle. They have to verticalize right now because of the state of the supply chain. So, do you go after missions that require large volumes of vehicle production in order to really make the mission work for that end market with the first generation vehicles? Or do you focus on missions that might operate at higher unit economics, but in lower volume, and then prepare the supply chain and participate alongside the second wave of vehicle manufacturers for going into these higher volume applications? I'm really trying to think, how would you navigate this set of questions, because you're working across a few different dimensions of consideration.
Yeah, no, I know exactly what you mean. And it's so fascinating. And again, being someone who's now a year and a couple of months removed from big aviation, traditional aviation, these are fantastic problems that we do face. Like, this is operational strategy, right? You think about it, you try to understand what makes the most business value, what's the most logical sense, and then you do it. And that's just, it's so refreshing and nice to be in this industry space. But look, there's a few things to unpack there. One was about the different missions, and do you go for volume or do you go for something that's maybe more niche, but some way to prove out what it is that you're trying to do? And another gets into the supply chain. I would say, in terms of the volume aspect, that's an excellent one. One of the main reasons to go for volume is production cost, right? It's just bringing costs down. We all see that there is a huge market if you think about how, just globally, what could these vehicles be used for if you have the right vehicle, whether you're talking military, civil, or any of those use cases I mentioned before. Worldwide, there's room for a lot of vehicles. So obviously the more you can address these different needs, the more you can produce, the more your costs come down if you don't have to, as you mentioned, if you don't have to continually redesign. Of course, there will be adaptation over time on the airframe side. So for one instance, of course, we do want to go for scale. But that scale will come, I'm not going to say slowly, but I don't think the ramp up, if you talk to the composite manufacturers, for example, the ramp up may come at a moderate enough pace that if you find the right, let's say, moderate use cases, you can, I think, will be more supply constrained at the beginning than demand constrained, I think. So that's why for us, some of these, as you mentioned, higher unit economics, when we talk about a little bit of helicopter replacement, not completely, but when you look at how helicopters are used today, there is a niche. And helicopter operators today are telling us there are some things they would love to use this for. They're very specific about what they want on their routes, and then they ask, can the aircraft meet it? And when you talk about these unit economics, by the way, this is something myself and Gonzalo Ramos, who I hired, who also came from my alma mater, I would say, we really understand that and get really into how can our vehicles not just say, hey, we can fly 100 miles and go somewhere, but specific routes, specific cases, what can we do? It's a lot of work, but you sell to the customer on that basis. And it might be smaller fleets, maybe more lucrative routes to start out with, but very good for route proving over time. And that's something that the Butterfly we believe is very versatile in that sense. Others may have, maybe with their vehicle, maybe a smaller scope of what they can do, but maybe for one particular thing, they do it very well. So I can't really speak for others. And again, the masses, that really comes with behavior change. People that are ready to commute around in these vehicles, making sure we have vertiports in spaces. That comes a little bit later, I believe. With regards to the supply chain, what I found is one of the fascinating things is in full supply chain in this industry sector, what's refreshing and nice is a lot of it are the same suppliers, right? When you talk structures, when you talk avionics, if you're talking about training, MRO, et cetera, these are people I've known for a long time, and it's been quite nice to talk to them about this new industry sector. And for them, there are challenges. Sometimes it's plug and play. Sometimes it's, well, we know you need XYZ component, but we have to think about if it makes sense for us to make it lighter, cheaper, et cetera. The dynamic that's different on the supply chain is that instead of these suppliers saying, whoa, we want to be on one of or both of companies in a duopoly, let's say, they're having to sit and decide, who am I going to work with? Because there's still only so many suppliers, and now there's lots and lots of eVTOL players that want to have their products. So they have to figure out which few are we going to work with, and I'm proud to say that Overair seems to be very attractive in that regard. So we'll see on the supply chain economics how that works out. But where it's really different are, as you mentioned, the motors and the batteries. This is really new, really different. And so there is a lot of, let's say, relatively large amount of, I would say, vertical integration, or at least internal development and design. And we all need things slightly different in terms of our batteries, peak power, et cetera, and in terms of the motor, geared, gearless, size, number. This is really diverse. And I think there's extra investment going into this, and it's hard to say how that's going to play out. You've seen that some companies have chosen, in the propulsion area, have chosen to exit the space. They were in, and then now they're coming out of the space. Maybe they don't see the economics. So I think that is one of those risks that we were talking about earlier, that we have to see. Where does this new bespoke supply chain, how does that shake out?
Right, or maybe they don't yet see the volume potential in the space to justify their continued investment in this part of the supply chain. But what do you think needs to transpire in the supply chain to change the equation for a new airframer? Say you have a new airframer that's planning to enter this market. What needs to transpire in the supply chain for them to credibly be able to decide on a strategy that doesn't involve them having to verticalize on energy or on propulsion or on some of the other key things that the current first generation of players are placing so much effort into?
Well, traditionally one might say convergence of designs, right? I'm not going to say it needs to transpire, but that is one big difference. Is not to say in traditional aviation everything is the same. Clearly it's not, but you have some understanding of what needs are, what designs are. So for the major component suppliers, being whether it be engines or avionics or anything else, the needs, the requirements are largely understood, and then you tailor it. For eVTOL, you look at all the designs, they are wildly different. And so some idea of fundamental, like convergence of fundamentals, I think would be helpful for the supply chain, not necessarily for the OEMs, but for the supply chain to be able to see that they can have volume. For propulsion players that are exiting, I know that they, and rightfully so, they were thinking, can we do a one-size-fits-all motor, or at least design of a motor that then we can tailor for each? And it just didn't work out, right? So I think there's some convergence there. Now, fundamentally, I truly believe that the long-term vehicle that will get the most utilization, that will serve the most markets, that will be the quietest, that will be the fastest, is the tilt rotor, is an aircraft that basically always has all of its propulsion working for it, as opposed to carrying around some propulsion that's not working for it in any given phase of flight. Right now, there are 2 tilt rotors out there. There may be others in the future. So I think some convergence of configuration over time may work, but it doesn't mean that only tilt rotors can work. It's just, if investment can be concentrated, then perhaps volumes go up and costs can come down. However, since there's so much of a market and there's room for a lot of vehicles in terms of number of vehicles, I think that there can be several different configurations given the right markets that can achieve economies of scale as well, if all works out well.
And with the first generation of vehicles, I think it's safe to infer, well, number one, they've really covered some fundamental new ground in the flight capabilities, but it's safe to infer that the vehicles, based on today's propulsion technology, today's battery technology, they're a bit heavier than we want. They're a bit more energy hungry than we wish. We're going to see improvements in that underlying technology going forward every year, the next 5 years. But from your perspective, what are the strategies that make it easier versus harder for those first generation vehicles to gracefully incorporate these improvements in the propulsion and the energy technology such that they can revise them in a fairly lightweight, streamlined way to be able to remain competitive in the market that's going to be with us in 2030 or the early 2030s?
Yeah, it's super hard to speak for all, certainly, but I just keep coming back to utility, right? If we talk about propulsion and energy, and those are 2 different things, I would say. So let me focus on energy management for a minute. I don't know how deeply each of the other players is digging into increasing the utility of their vehicle by ensuring that the vehicle can fly everywhere it needs to go, right? Can manage hot and high conditions, can manage Cat A, right? To be able to, with a critical loss of thrust, still be able to have controlled flight to come back around and land, right? There are going to be some places where that's required. when we talk about how to manage power based upon how long you can be on the wing, how quickly you can transition to vertical, right? These are things around the vehicle design that matter. That's where our tilt rotor comes in. Think about military, for example. Overair happens to come from fundamental vertical lift technology that enhances efficiency of vertical lift with the optimum speed tilt rotor, the individual blade control work that was worked on by Abe Karam and Ben Tigner for years. And then they were like, wow, we have a technology that can be applied to this new industry, right? So therefore, we are already thinking about energy management. Therefore, perhaps we can better manage the, let's say, limited somehow energy that's coming from batteries, right? So you've got to really be able to adapt. And in some cases, we say, okay, how are we going to manage critical loss of thrust? Are we going to really be able to do Cat A? How hot and how high can we fly? And I think this is where use case limitations, design limitations, and configuration changes are how different players are going to have to meet. Meanwhile, batteries will get better. But some things will never change. Well, never. I don't want to say that because who knows. But batteries don't lose weight, right? So how do you manage your equally heavy vehicle, unless you've thrown something out of it, at a very critical time, very low charge of battery, high power need, vertical landing? How do you manage that? Well, that's going to be through configuration and ConOps. Configuration of the vehicle and ConOps. So those are just physics. So I don't know how everyone's going to manage that. I know how Overair is working on that. And then the propulsion, again, I think these motor designs, from what I've seen, and it is fascinating, electric motors. I had to learn a lot, bone up again on the electric world over the past year. There are so many possibilities that I can't begin to say where there might be some convergence and how some may address. I think people are really just going to have to depend upon a good supply chain and scale to bring that down. But I personally don't know, and I'm not the world's expert, but don't know that there's going to be a convergence on motor design in the near future between different players.
Yeah, I don't know if there will be on motor design. There are so many different vehicles to be built in different sizes that we might see convergence in motor architecture. So motors that are lightweight, really good at managing their thermals and able to deliver high torque at low RPM. I think those are common design objectives that we see at all scales. But boy, building one motor of one power spec and then seeing all the airframers design around it, that still seems pretty far off to me.
I agree, absolutely.
To what extent is this a market where the first mover gains a long-term advantage? And perhaps we can take a page from traditional aviation, where if you look at the jet airliner market, Boeing dominated it early on as an early pioneer, whereas Airbus joined the race, 25 or so years later, and based on the current market dynamics, that didn't really hurt them. So argue both sides of that argument.
Well, I'm biased, right? We all know my background and really appreciate all my time with Airbus, certainly. But no, it's true that I think in this, there's a difference here. There may be eVTOL players that don't exist yet, right? That will come in 10 years after everything's established, that known that this is an industry, this is a mode of transportation, they have a new innovative idea, they do something slightly differently, come in from the beginning without the baggage of having had to be part of starting up the industry, and they succeed by being more efficient at something that today, including Overair and others, aren't. Right? That could happen, and that's more, there's no way to argue against that because that's in the future. I think for today, first mover advantage, like I said, I think switching costs it's a different entity than in eVTOL than in traditional aviation, right? And this comes back to why are so many eVTOL OEMs planning to operate the aircraft, right? Because there are no operators out there, and I'm exaggerating a bit. You have some of the helicopter operators, et cetera, who are saying we want to replace, like I already said earlier, yes, we want to fly from A to B. Some of our routes could be replaced tomorrow by eVTOL. Boom. That's great because they know what they want, they know what they need, and as I said, you work on these unit economics, specifics for them, can they charge, can they not charge, infrastructure's already there, great. So if you move that aside and you get to, let's say, passenger transport for the typical AAM, UAM, you don't have these established operators that you have to make them switch. One thing in traditional aviation over the past, that's another thing that happened it was pre-COVID, but also post in some parts of the world. You have just startup airlines, especially when money was cheap. You have airlines starting up. And you're like, okay, a couple of people say, all right, we have some money, we want to get a couple of planes. They go to the lessors, and then you can compete for their business. But as far as switching, we don't really have that right now. So I think, and there's enough space to go around. So it's a very different animal because the transportation, let's say industry related to eVTOL, the operator and the OEM growth is happening at the same time. And you don't have national brands, you don't have mixed fleets, you don't have any of that yet. So that's where a lot of the uncertainty comes in. Also, the aircraft don't fly very far, right? If you have, let's say, an Overair operation in Dallas, Fort Worth area, North Texas, please, I don't want to get in trouble by saying the wrong things, the Metroplex, right? If you have an Overair operation with Overair butterfly aircraft today, that is not competing with, somebody else's operation with somebody else's aircraft in Kansas City. It's just not competing, right? So, and you may be able to get enough scale to really work out your route proving, et cetera. Now, in the future, in North Texas, you may have somebody else's operation operating Overair butterflies and operating another eVTOL that's better suited for maybe tiny short routes with 1 or 2 passengers instead of let's say a longer route with 5 passengers, and that's okay. You'll have a mixed fleet operator. So it's really hard to say the dynamics and what's going to happen, but certainly if the vehicles are not cost effective and quiet, I'm taking safety off of the equation for right now. I'm going to make that assumption of safety that we're all trying to achieve the same goal. But if they're not cost effective and quiet, they will not last a long time, right? These are aircraft that are single digit millions with, we're still working out, let's say, usable life, residual values, etc. But I don't think it's going to be quite as challenging to switch. But it's going to be fascinating to see this go.
Valerie, help me out with this. Is Overair intending to be both the OEM and the operator when you go to market?
So it's not our main objective to be an operator. However, we do need to start to, just as in traditional aviation, the OEM needs to know its aircraft. It needs to know what the aircraft can do. It needs to know how to be efficient. So there will be some early on aspects of being the operator, and at very least being there with the operator, assisting the operator. As I said, we have some customers who are just doing helicopter replacement, but they don't exactly know, right? Part of my main job at Airbus, which I loved, was running customer support, running this aspect of, though most of the company is ready to get the aircraft ready for the operator, my job was ready to get the operator ready for the aircraft. I say that a lot because it's so key. Those N-X years, right? We're going to go into service in year X. Depending on the aircraft, depending on the experience of the operator, you're starting year X minus 1 year, minus 2 years. In some cases, there was one customer who wanted to start 5 years in advance. And what are they doing? They're learning how to do it. They're training, they're getting their spares. You're sending teams of people on site when the aircraft gets there. Field service, engineers, supply chain people, digital people. And it's, especially for a startup airline, I think it's underappreciated how much the OEM is involved, right? It's not my dream to sell tickets to people and it's all going to be digital, and people are like, oh, I'm late for where's my luggage? That's not my dream, but the OEM anyway is going to be a massive part of making sure that these aircraft operate. So ultimately, having a Part 135 for a certain element of time makes sense. We're working a lot on the software aspect of this as well, both on the pilot, the passenger side, the OCC, and the pilot, because I think it's also underappreciated how, in order to increase the utilization of the aircraft, how much you have to really plan for ride sharing and for how these aircraft are going to operate. It's something I underappreciated a year ago, so we have a great team working on that here. So again, that all has to be proved out so that we can set it up for ourselves, and then in the future, where we really want to go is into a model where we're helping others start up their operation with our aircraft, with our software, with our services. But we just have a couple of views. Obviously, we're located in Southern California, so doing some operations in Southern California makes sense. And then I think wouldn't be a surprise to anybody at this stage to see that North Texas is a target of ours to get some operations going there. And then really, if that goes well, we're helping others operate and we're getting our vehicles out there on the market.
Do you worry that in some circumstances, taking on the complexity of being the operator in addition to being the OEM is essentially a bridge too far for a startup?
I don't know if worry is the right word. And I don't think necessarily a bridge too far, because however you develop the company, you can prepare, right? These companies are greenfield. Think about it. I'm an aviation person. This company, Overair, is based on an aerospace foundation, right? Defense, which is also a good target market for us, but it's a foundation of understanding the complexities of design. There are other eVTOLs out there, these eVTOL companies, bless their hearts, that started from hey, we want to do this operation, and okay, let's build an aircraft, right? They don't have the same fundamental aerospace bona fides that we have. But they're going a bridge, not too far, but they are going over a bridge, right? So I think if we develop the company as for example, our software group here, there are some aviation experts, but they're mostly transportation experts, right? We've got a team that they haven't designed aircraft, but they know about transportation, they know about ride sharing, they know about software for this purpose. And I'm getting in there talking about whenever you get to the aviation specific software, right? Like EFBs and things like this. But so if you build it properly, you're not just thinking of yourself as an aerospace company. You're thinking yourself as a part of transportation. So in that sense, I think, no, it's not a bridge too far, as long as you segregate properly. I just think that for the long term, it's likely that it doesn't make sense. It's likely, but things could change. The world has changed several times in the past. It may change in the future. To have all that under one roof, where you're really fully trying to go fully vertically integrated from the passenger all the way to the raw materials, is a lot, right? But I think what's more important to me is that in order to have an economically viable aircraft with high utilization, you need to know it and inside and out. And unless you have a really savvy operator that already knows as well, and you're in there learning together, you just got to start something up. So that's the idea.
It's interesting that you pointed out that in this space, because it's a new type of mission, there really are not existing operators that are doing this that you can hand the vehicle over and that you can stay close to and learn from. And so a lot of people conclude, well, we're going to do the operation ourselves and we're going to learn from it. Do you think that the size of the business opportunity in that operation, in other words, how big can it be? Can it be the Uber of the skies versus something smaller that is taking just a piece of existing helicopter operations? Do you think the size of the opportunity impacts that strategic business decision for the company?
And I hesitate only because we have this debate internally quite a bit, because there are people in the company and around the world who believe that the operation is where it is, right? Unlike, I think, in traditional aviation, famously, the further away you get from the passenger, the more money you make, right? So somebody making some of the oversized fasteners is making quite good money, and whoever's selling the tickets and putting people in the aircraft are not necessarily making as much money. I think we have the opportunity to change that paradigm in this industry. There are those, and usually they're not the aviation traditionalists, who believe that there is more money to be made if you own the passenger, right? The numbers, you can build a model that looks great on that. You have to make a lot of assumptions about how much people are willing to pay to fly per mile, how often they're going to fly, what's their disposable income, what's the infrastructure, how much utilization you can get, how many deadhead flights, etc. But there's a world that says you can make a lot of money close to the passenger. But I am an aviation traditionalist. I don't say it's wrong. I do say that I think over time, people who just concentrate on that, and they aren't building the vehicles, they aren't writing all the software, but they're taking what's there with good supplier-customer relationships and concentrating on the passenger, concentrating on operation. I can't help it, but as a traditionalist, to think that's probably the future, because when you focus, you go quite strong. But I think we're a ways away from that. Most of when I talk about like some of the vertical lift operators today we're selling to, they're not particularly high utilization, right? The military, not particularly high utilization, not particularly tricky, right? If you think about, it's not about, I don't know if this answer is going on too long, but if I'm sitting here in Santa Ana at our facilities in Southern California, a stone's throw from John Wayne Airport, right? But also a stone's throw from several other airports. And I want to go to downtown LAX. Well, it's not about me saying, hey, I'm going to go to John Wayne Airport, pick up an eVTOL and go to LAX. I'm just going to go into my app and say, I want to, not LAX, let's say downtown LA. I want to go to downtown LA. Everything else has to be done behind the scenes. A car is going to come pick me up. Is it going to take me to John Wayne Airport to that eVTOL? I don't know. It might take me somewhere else because the John Wayne eVTOL is full or is broken down or isn't going soon enough. But it helps to optimize the fleet for me to go somewhere else. I don't particularly care as a passenger. I just want to get up there, and I've toggled that yes, having an eVTOL is okay. If you talk about, let's say, the Uber of the skies, right? Depending on who's optimizing the ecosystem decides where the value is going to be created. You need to optimize the aircraft fleet to create value for the aircraft. So by sending somebody to a different vertiport, et cetera. So there's a lot of specialism I think that's going to come. We're just developing that out right now to make it possible, and then we'll see who actually does that in the future, if it's franchise model, et cetera.
That's fascinating. This discussion really brings into focus for me the fork in the road that the industry is looking at in terms of how do we bring, fundamentally, we're thinking, how do we bring new technology that manifests in these air vehicles that have new capabilities, right? And how do we bring that into the market? And with the eVTOLs being employed in a transportation as a service mode, we're looking at one route. And in many cases, that raises this question of, does the OEM also take on the operations for the reasons that we've discussed? But in addition, there's this other route over on the side that is building an aircraft of a different size, perhaps a different configuration, and bringing it into a market where there are existing operators that can pick it up and start using it, and it looks and feels just like another tail number in the fleet, or creating the technology to build an aircraft that can sell into the general aviation community more broadly through what hopefully will be made a rule through the Mosaic NPRM, and going in that way. It's two very different opportunities with very different journey for the startups that are doing it, a very different risk profile. One that kind of straddles in the middle that comes to mind are the companies that are building the electric short takeoff and landing aircraft, and perhaps taking a different path with the technology, the design of the aircraft, the certification path, but selling into a very different type of market where perhaps there are existing operators. This is just surfacing that contrast for me, and I think in a very vivid way.
No, it's interesting. Yeah, exactly. And I just talked about how much the team has been working on the software side, the kind of transportation focus. We have a team on industrial design, performance, that is working with the flight deck team, working with the program team very closely on about from the inside out of the aircraft about how it is to operate. Of course, I mean, there could be, and there have been podcasts about, the big SVNO of simplified vehicle operations. What is that actually? Maybe we talk about that a lot in Gamma, et cetera. Of course, what's the training going to be like, et cetera? How, let's say, easy that may or may not make it to put this aircraft into different types of operations. One thing we have to think about, of course, again, is the cost, right? Developing, it does take money to develop these aircraft, and not just the design and the certification, but the initial production and the supply chain, right? So you got to recoup that somehow, and you have to recoup that with volume. And so to sell it, 1, 2, 5 at a time doesn't necessarily get you there. Although early on, it can help. I'm happy to have 5 aircraft go to replace 5 helicopters in a given operator's fleet to help for route proving, but long term, it doesn't necessarily scale. So I think scale is one of the things that's going to drive it. But yeah, I think there are various opportunities, especially once you come down that manufacturing curve a little bit, and the costs and hopefully even prices can come down. But yes, regular specs are going to have something to say about that.
Valerie, you call yourself a traditionalist. And as such, how much inspiration and lessons and insights do you draw from the way that jet airliners have been integrated into the air transportation industry in the past, in the 50s, and how the air carriers themselves changed or have not changed by the introduction of jet airliners? How does that inform your thinking about how this market might unfold?
I don't know. I've said this. I don't know if I am actually a traditionalist. I do come from traditional aviation, worked with airlines all around the world, all different positive and challenging aspects. But really, I think the main point is not so much the aircraft. They get more efficient, they have different materials, that's all great. But it's the digital part, right? It's the data and how that data is used and how that data unlocks even more value for the OEMs and for the airlines, and by the way, everybody in between, or maybe not so much in between, but the entire supply chain. The fact that we can do more predictive maintenance, the fact that we can do more, fleet optimization, the fact that we know where the aircraft are all the time. We still haven't hit everything in traditional aviation, meaning we still pull delays. Everybody knows that there are going to be delays into a certain airport on Tuesday morning. Nothing ever goes as planned, but we still plan the same way. So there are still things that can be improved. These aircraft, at least our aircraft, it's a all-electric, fully digital, fly-by-wire aircraft, right? We are building in from the beginning. This aircraft is going to produce a lot of data, and we're working on who needs the data, how often, for what. And when I say who, it's who within program, engineering, of course the operational control center, the pilot, the engineers, support services, who needs it live, who needs it just after every flight, who needs it every day, etc. The aircraft itself can be a digital native, and I think that when you talk about battery management systems, you talk about pilot training and being able to do evidence-based training based upon all of this data, I think that's going to be revolutionary. We can go really a step further than anyone in aviation is going now, and that will help safety, that will help cost, and that will help to unlock value. And I think that it's going to be really, an amazing change if we do this properly.
Valerie, if we were in your office right now, we looked up at your whiteboard, and you, as the Chief Commercial Officer, you had a 3-year plan on the whiteboard. What would it say? What's excellent achievement in years 1, 2, and 3?
That's a good one. We have to fly. We have not yet flown the full-scale prototype. There are reasons for that. We weren't rushing to fly a non-representative prototype, but if you were to come not in my office, but just outside of my office and then look through that glass door into one of our main hangars, you see our first full-scale prototype, nicely wrapped in white. It looks like an airplane, having some shakedown test before it goes out to our test facility in Victorville. So, we have to fly and get into that flight test campaign. That means a lot for the suppliers that have been, working with us, the customers, and of course investors and everyone else. So, and for the team, it's most important for the team, right? So that's very exciting. So that's getting really into that flight test campaign is very important. In parallel to that, increasing our outreach on the, you saw what we did with Dallas-Fort Worth, City of Arlington. We've got some in the Los Angeles area, increasing our outreach with our, let's say, various ecosystem partners around the world to help get the world ready for our aircraft. And that comes in various forms of LOIs, MOUs, but really being able to follow that up with true work that's meaningful to help us mature our concept of operations, to help us mature our software, and to help us mature our support and services that we're developing. And then I would say the last thing is getting ready for the operation, right? Because again, from the time we start testing our aircraft, from the first flight, we are going to be testing with third-party validated noise signature, right? We are going to, of course, be working with the authorities and continue to work with the authorities because we have made a lot of progress with the FAA on making sure that we're ready, smoothly, hopefully, ready to kind of go into service after certification. Part of that also involves working with, various militaries, right? So it's just really advancing the aircraft, everything around the aircraft, and then the, of course, commercial and operational aspects of the aircraft. So that's what our next years are all about.
You mentioned earlier that infrastructure requirements, depending on the mission of the vehicle, are not as significant as most people think. If you just use today's infrastructure, there's a lot of value you can create without having to create new requirements. Why are the relationships with DFW and LA so important right now? Why are they in your top 3 priorities? How does it help drive value to your potential customers? What's the added value that Dallas and LA provide?
First thing on the infrastructure is, definitely to fully scale in advanced air mobility, at least vertical lift, bespoke infrastructure will be needed. My point about we have quite a bit of underutilized infrastructure in various parts of the world that we don't need to wait for the bespoke infrastructure in order to start creating value. That's where I'm getting at.
Right.
So for LA and for Dallas, Fort Worth, greater metroplex, I'm starting to learn about the sensitivities of that area. The point is first of all, you want to be somewhere where you want to be present, somewhere where you have ecosystem players that want to work with you. And in both cases, these are not the most They're densely populated, but they're not a densely concentrated one downtown city of tall buildings that you're trying to fly over. So there are opportunities to have diverse use cases to, shorten the distance between 2 points in a way that might be far away, to use these existing infrastructure to then create bespoke infrastructure inside of that existing infrastructure, putting a vertiport at DFW, at Arlington, thinking about how to adapt existing heliports in the area, but having the airspace to be able to do some route proving. So that's really what it is. I mean, it could have been elsewhere, but these are really welcoming partners. And another thing for LA, of course, is it's a nice ambition to be able to participate in the innovation that the U.S. would like to showcase, or should like to showcase, when the LA Olympics come here in 2028.
Great. Thank you, Valerie. Hey, what was your impressions and viewpoints of all the announcements a couple weeks ago of the OEM participants in the New York area? What was your reaction to that?
Well, I was excited. I mean, more power to my friends in the industry. If New York City starts to accept, so that's great. It was exciting to see the mayor support it. And because, again, I've mentioned a few times today noise, like noise. And we understand that New York City is one of the places that is not so excited about helicopters and helicopter noise in general. So it's nice to see some positive reaction. It's a good signal to the market in other cities. That's the king. It's about being a signal. I mean, New York City is an attractive market if one thinks about just the pure ability to make money if everything is unlocked. It's a huge market. I believe there are high barriers to entry. There will be quite a bit of competition there. So I don't necessarily have desire to be there first as an operator. And by the way, I'm not anti-New York. Both my parents were born and raised in New York City. My brother was born in New York. But overall, I think it was a very good message, and I'm glad they were able to do it.
Valerie, I'm really curious, talking about the use cases in the different markets. As a chief commercial officer, you must be thinking about this constantly, but give us an insight into the discussions within and among your team about choosing the right go-to-market strategy, choosing the right use cases to go after, and in particular, the choice between pursuing this UAM or regional use case where there are, as we discussed, no current operators that you can hand this aircraft to, where there is no clear demonstrated de-risk demand for services. There's so many assumptions that it almost hurts. Yet on the other hand, you might say we can go serve the GA market, or a market where an introduction of this kind of vehicle doesn't represent such a big shift in assumptions and behavior and willingness to purchase, et cetera, et cetera. So how are you thinking about this trade-off?
Well, I would say it's a little bit of all of the above. That's one of the beauties of the Overair tilt rotor design being so versatile. I really do see it as like kind of the utility vehicle where we don't have to sort of design to meet different markets. But we are looking at both. Look, use cases, regions, geographies, they'll all mature at different rates. And early on, where there's appetite and interest and clarity of thought from some existing GA or say helicopter operators that know that they have 15 routes and 46 helicopters, I'm making this up, and several of them are maybe at fixed times and over a fixed distance, and they would like to, right? These are interesting targets, and we like talking to them. We can educate them about our vehicle. They can see if it fits, especially if it's an area where we would like to go or we know we can help them. So that's definitely something we're going after. That does not preclude us from trying to open some new opportunities. There are some airlines out there, there are some other operators out there who are thinking about what to do, and we are talking to them, but I don't think that precludes us from going to try to address use cases where our vehicle can shine. I mentioned a little bit earlier the hot and high, like mountainous areas. I mean, the tilt rotor, especially a tilt rotor with the size of ours, has a great opportunity to serve from the city to the mountains, for example. And these can be pretty focused customer base for early use cases, right? So I don't think we just have to pick one or the other. We do have to think about, spreading ourselves thin. Are we able to set up? But we have some years to build that. So I don't really see it as one or the other.
When we were preparing for the podcast and when we were looking at your vehicle and its capabilities, it appears to be a very low-risk vehicle and that the likelihood of execution is quite high, in my opinion, versus some of the other vehicles out there. One of your greater value sets was noise, lower noise. How much greater value is the lower noise to the customer? And it sounds like your noise levels may be lower from those who take great pride in having low noise levels. So how much greater value is the lower noise, let's say the community in the New York area? How do you guys quantify it? And is it worth the extra cost of creating lower noise?
Well, first of all, I'm sure the program team will be overjoyed to hear you say that you believe our aircraft is lower risk. So I'll let them let them know that. I mean, I think noise is so hard to quantify right now, but it's going to be critical because what we're trying to do is, we as an industry, we're trying to do is increase the volume and the number of aircraft that are flying even closer to people than the helicopters are today. So yes, we can quantify it, 55 decibels, 65 decibels, etc. It's funny, I have a watch where I always have my decibel meter going. I'm always looking at it just to try to get a feel for, somebody's talking, that's 45. Oh, somebody just yelled, that's 75. It's quite hard. And from traditional aviation, and I talk to airports, including John Wayne Airport and Luton Airport, where you have the people who are always complaining about the noise. And like, there wasn't even a plane overhead. Why are you complaining about the noise? Oh, but every day at this time. So there's so much about perception when it comes to noise. The more we push on true noise, the better it will be that we start talking about, visual pollution, noise pollution. It's just going to be invaluable. So as far as extra development, I mean, the beauty of Butterfly is that it's inherent in the design, right? The fact of the matter is we have 4 rotors, 4 propellers that have a diameter about twice as large as the next largest in the industry, which simply means they're turning more slowly. And so you have lower tip speeds, and so you have lower noise. On top of that, with our individual blade control, the optimum speed, individual speed of each of the rotors, being able to have that optimum trajectory of the blade as it's going around, no swash plate. Everything's in there to reduce vibration, to reduce noise.
We had Dr. Bourdain on a few weeks ago, and during that podcast, we talked to really get to the level of profitability required in UAM, that we needed to reach a level of full autonomy, not just autonomous, but full autonomy. Over the next 5-10 years, where do you see the role of UAM as it relates to autonomy?
That's a topic that gets talked about quite a bit. One thing I want to tie back to is what I was talking about at the beginning about flying in Europe versus flying in the US, etc. I mean, one aspect is scale and accessibility. Much of the world does not have just free skies where people do just drive over to the airport and hop in there, pick your GA aircraft of choice at age, however young to however old, and just fly around. You can talk about Korea, Singapore, China, some places in Asia, other places in Asia where, the sky is very small because it's a small country or it's managed by the military. So you don't have just this plethora of pilots flying around. So in some cases you might say, okay, that increases costs. Some cases you might say that's going to drive a path to saying if you're going to have aircraft operating because you just don't have enough pilots, period, that could drive a speed to autonomy. I think that, autonomy is going to play a role. I think really what's very important at the beginning is automation, and there's automation with a path to autonomy. And, autonomy, that's a big word, right? That is it autonomous, meaning just the autopilot's doing everything to auto land? Is it that the aircraft is making its own decisions? Is it the aircraft is rerouting itself because it senses weather? I mean, it's just a sliding scale. I mean, I think it's going to advance. This will come into vehicles. And it will come. I don't know at what pace, because then there's social acceptance and regulatory acceptance. The aircraft will be capable of being autonomous before they're allowed to operate autonomously, I believe. It definitely plays a role. As far as the profitability, I would not personally go so far as to say it cannot be profitable until. I do understand that a decent part of the cost, and we do work quite a lot on unit economics here in our commercial team. A decent part of the cost is piloting cost. However, a big point about having a pilot is also about utilization of the aircraft, right? And here, these flights are so short, you're on the ground so often that I don't think it's not going to be the pilots that limit the utilization. I mean, I think the biggest profitability driver we see, I'll simplify for effect and say the biggest profitability driver we see is how many hours is your aircraft in the air, right? From how many operating hours a day, from turnaround times, charging times, deadhead flights, maintenance, out of service, anything that you can imagine, TFRs, etc. That's if you can fill the aircraft to a reasonable load factor, which I know is an if, but that's regardless of whether there's a pilot in the aircraft or not. That utilization is key. And yes, pilots are part of that cost, but they're not driving the utilization. So first we have to get people wanting to fly in these aircraft, have to get the aircraft at high utilization from a maintenance standpoint, from a regulatory standpoint. And then yes, you increase profitability if you can perhaps lower the human cost. Perhaps that has an impact on safety. Perhaps that has an impact on accessibility because you don't have to train so many pilots. We'll see where that goes. I mean, yeah, it's a big and interesting question.
Valerie, what advice would you give to someone who wants to start a business in this new chapter of aviation?
Well, it's a unique opportunity, right, to help write the rules and the playbook for all aspects of the industry. It's possible that profit sharing and go-to-market could be very different than traditional aviation. So one piece of advice I would give is don't only think of it as aviation. We are a part of transportation. We are a new mode of transportation that ties to the rest. And so I think that's one piece. Another piece is don't be naive. Take the regulations, rules, safety requirements of aviation seriously. And the last I would say is be clear, and this goes to being naive, be clear that there is a lot of capital required in advance of revenue generation. So you really have to have conviction regarding the addressable market you're target. And frankly, that's regardless of whether you're an OEM or even an operator in the early days. There's still capital requirements, right? So, so I would say that, but it's a fantastic world. I love being in it.
Valerie, is there one point that you would like to leave the audience with as we wrap up?
Well, again, I think I built this in somewhere, but I am so glad that there's a push in aviation and aerospace that can serve to attract new talent and passion and help us compete with industries. And that's advanced air mobility, as I said, that's hydrogen, there's new space. It's really exciting to be able to be part of something that's really innovative, but it's something that's so fundamental to kind of the heritage of the industry as well. So I encourage people to become or stay involved.
Thank you very much, Valerie. It was a real pleasure to speak with you today. All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.